open the settings icon, select the autofocus menu to run the focus widget. You can also use Ctrl+F to launch it. Here you can set the range of autofocus. In this particular setup, the AF lens range is 20 mm along the optical axis. You can limit this range of the autofocus to speed up the focusing. Select the deepest sharp point with the slider and click on the Set button at the AF range minimum. Also, you can select the highest sharp level by adjusting the slider and clicking the Set button at AF range maximum. And the same way, you can adjust back the minimum and maximum limits of the AF lens. Click on the 3D icon to make a hyperfocus image. At height magnification, the depth of field is shallow. Either the high level or the deep level is sharp. This comes from the physical limitation of the optics. Here you see that when we focus on the top of the chip, then the green base plate below is blurred. If we set the base plate sharp, then the height part will be blurry. You cannot have everything in focus simultaneously on a live image. SANXO provides you solution for this problem using multiple images. Select 3D, go to Calibrate menu, load the 3D calibration file. We use Tamron 50mm lens at the infinity settings. Now you go to Capture menu and set the exposure time. If the image has lots of dark and bright parts, use more than one exposure time. Select the deepest and the highest sharp level with the sliders. Using the first slider, set the lowest part, and using the second slider, set the focus to the highest part in the image. Select how many layers, meaning how many pictures with different focal points, you want to combine. Usually, around 20-30 layers will give a good result. Select different methods of image generation to find the best fit to your sample. Adaptive filtering is usually very accurate. If there are dark and bright parts, the Robust 2 method gives good results. Press Start to generate the hyperfocus image. The microscope now takes 20 images with different focal points and creates the optimal sharp result. It takes about 20-40 seconds. If you add more exposure time, it will take more time. If it is ready, then click on the Yes button to see the hyperfocus image. Now everything is sharp from the bottom till the top. This hyperfocus image is ideal for documentation and for measurement too. If you quit from the image viewer, you can select the 3D menu to generate a rotatable 3D image. A mesh surface will be created based on the previously taken 20 images. Rotating your sample into 3 dimensions is ideal for demonstration or marketing purposes. Remember, this 3D image is not complete. The camera cannot see through the objects, hence it cannot show the hidden parts. The last function is the image viewer. It loads in the last saved hyperfocus image, or you can load any of the previously taken images. This image viewer is ideal to make precise measurements on a still image. You can place a wide range of overlay elements to make measurements and comments on your image. Here you see the last selected function. You can pick them up from here as well to speed up your work. For example, you can place points on the image and measure different distances. Select point-to-point function. Then on the right side, select starting and end point from the roll-down menu. Red field always shows that you need to fill it up. See here the distance between the two given points. Now let's place a line on the image by selecting the line icon. Just place some points approximately along the line, and the function will interpolate between your points to calculate the best line fit in. You will get a corresponding ID of your line. Here it is L1. This function measures the distance between the line and the point. Select the line and the point from the right side at the roll down menu. You see here the distance between the line and the point. Now I create another line in order to show another distance measurement function. If you have parallel lines, you can measure the distance between them with the line-to-line function. The parallelity of these line segments should be 97%. The circle function defines the diameter of a circle. You need to give at least 3 or more points, then click Finish. Then select diameter measurement from the measurement function and select your previously made circle from the roll down menu. Here you see the elements you have placed on your image and also the measurements you made. On the right side, in this list, you can see all the elements and measurement functions you created. You can also edit the place of the dimension figures, hide or delete the elements. As you see, we can move and rotate the dimension figures of the measurement functions. Let's save the measurements as a project. You can export the saved project into a CSV file or as a PDF report. Give a name and save. You will receive an illustrated measurement report with the magnified image and the measurement values formed into a list. If you need customized measurement report, contact our support team. Thank you for watching SANXO Digital Microscope tutorial.